property properties of F range. Jesus, my daughter, I helped her to make a present, and the appointment is 3 o'clock. She was late. Jesus. Okay. Okay. X minus A. X is equal to X minus A with a heavy sign, X minus A. And here I want to show the diffraction derivative of a heavy side function, X minus A, equal to what? Derivative. Something like this, right? For x smaller than a, what is the derivative of a heavy side? 0, right? 0. And at a, what derivative? Infinity. Okay? And after a, it will drop to 0. What is function? This function we call the delta function. Delta function. Have you learned this delta function before? No. Really? All right. Okay. So this class is today is a mathematical class. Yeah, direct delta function is a very interesting function. So the first time he appeared, and the mathematician said, "What this? It's ridiculous things." It's developed by a physicist, okay, or engineer. Delta function. It's about later on the mathematician they accept it, and I think they think this very interesting, unique, and very important function. Okay. So for this, let's see. This is the delta function. Okay. And the delta function is defined by this way. This is at A, okay, and this is this distance is 1 over k. Okay. And the height is k over 2. Okay, so the area equal to 1. Okay, and this is x-axis, and this is x equal to A. Okay, located center at A. Okay, so we call this function, we call the WK x minus A. Okay, so WK x minus A is defined as for x minus A, the value is less than equal to 1 over k. Within this range, and this value is k over 2. For x minus A, value larger than 1 over k is equal to 0, right? So for this function. Okay. Then, when And this function, this area, is equal to 1. So for the limit k approach to 0 of w k x minus a is equal to, for k 0, right? That means, no, sorry. It's not right. It's sorry. Sorry. For k to infinity. Okay, sorry. For k to infinity. For k to infinity, and that means this getting smaller and smaller, right? And the height will be getting infinity. That's what we call the delta x. Okay. So this is a definition for the delta. Okay. See what I mean? For k become infinity, the length is 1 over k, getting smaller. But keep the area as 1. But this height getting to infinity. Okay, so this is a definition for delta function. So that's why heavy side 0 and infinity. Outside 0. Okay. And this, you can see this is the width. This is a width, but the width is very thin. It's the area. Right? Another important property for delta function is when you operate with some function, is equal to x equal to a, and this is my wk. This is k over 2. And this is 1 over k. 1 over k. Okay, and this x. And this is another function. For example, we call it gx. Okay. Then I do this kind of integration from minus infinity to infinitive wk x minus a times gx dx. Okay, for limit k approach to infinity. What this integration will be, and this will be limit k to infinity, and for the effective domain is from minus a minus 1 over k to a plus 1 over k, right? This is a minus 1 over k. This x a plus 1 over k. So domain of non-zero part here. And inside the domain, this value is k over 2. And the gx dx. Right? Alright, so because my integration is about x, so this can take out. Then I have limit k to infinity k over 2. Okay? And the integration of this part, okay, a minus 1 over k, a plus 1 over k, gx dx. And this integration k can use in the something like a mean value theory. Can we use a g as some c value? Because c is between that one as a height, representative height, times the is 2 over. Okay. This is the area, right? So this area can be used as some value g c. Because this is between this range, okay? And this domain is 2 over k. Okay. And so this is a mean value theory. In the calculus, you have learned this, right? Mean value theory, calculus. Yeah. So you can see when the k getting infinitive, and this cursive value will bring to 8. So for k infinitive, this will be k over 2, 2 over k, and g and 8. So this is a very important formula we got. In the future, sometime you are doing this integration minus infinitive to infinitive of fx times delta x minus a dx. Okay, this is equal to f at 8.